Gravity. Gravitation or gravity is a natural phenomena by which all physical bodies attract each other. Gravity gives weight to physical objects and causes them to fall toward one another. In modern physics, gravitation is most accurately described by the general theory of relativity proposed by Einstein, which describes gravitation as a consequence of the curvature of space-time. For most situations, gravity is well approximated by Newton's law of universal gravitation, which postulates that the gravitational force of two bodies of mass is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. In pursuit of a theory of everything, the merging of general relativity and quantum mechanics, or quantum field theory, into a more general theory of quantum gravity has become an area of active research. It is hypothesized that the gravitational force is mediated by a massless spin tube particle called the graviton, and that gravity would have separated from the electronuclear force during the grand unification epoch. Gravity is the weakest of the four fundamental forces of nature. The gravitational force is approximately 10 to the power of 38 times the strength of the strong force. Gravity is 38 orders of magnitude weaker, 10 to the power of 36 negative times the strength of the electromagnetic force, and 10 to the power of negative 29 times the strength of the weak force. As a consequence, gravity has a negligible influence on the behavior of subatomic particles and plays no role in determining the internal properties of everyday matter. On the other hand, gravity is the dominant force at the macroscopic scale. That is the cause of the formation, shape, and trajectory orbit of astronomical bodies, including those of asteroids, comets, planets, stars, and galaxies. It is responsible for causing the Earth and the other planets to orbit the Sun, for causing the Moon to orbit the Earth, for the formation of tides, for natural convection, by which fluid flow occurs under the influence of a density gradient and gravity, for heating the interiors of forming stars and planets to very high temperatures, for solar system galaxy stellar formation evolution, and for various other phenomena observed on Earth and throughout the universe. This is the case for several reasons. Gravity is the only force acting on all particles. It has an infinite range. It is always attractive and never repulsive, and it cannot be absorbed, transformed, or shielded against. Even though electromagnetism is far stronger than gravity, electromagnetism is not relevant to astronomical objects, since such bodies have an equal number of protons and electrons that cancel out, a net electric charge of 0. Read about gravitational theory, scientific revolution, Newton's theory of gravitation, equivalence principle, general relativity, gravity in quantum mechanics, Earth's gravity, equations for a falling body near the surface of the Earth, gravity in astronomy, gravitational radiation, speed of gravity, anomalies and discrepancies, alternative theories. Read all about gravity. Gravity. Gravity.